Hello and welcome to STEM with Mr. N, where I perform different demonstrations and explain the science behind what we're seeing. For this week's video, I've teamed up with the Antidotes pollution solution and I'll be debunking some fake science as I explore invisible water quality. Let's check it out. The Antidotes pollution solution was written by public health expert Patty Michelle. It follows a group of 5th graders shortly after their lives have been disrupted by a pandemic, and they are now facing another disease that is affecting their town and the rest of the world. Together, the children decide to team up to become disease detectives. This book touches on lots of different elements of STEM, including public health, water quality, pandemics and girls' achievement in STEM, and it's an excellent way to introduce children to lots of different STEM subjects, as well as showing that children can be agents of action in the world. In the book, the children decide to test the water quality between their home and the school, and they discover harmful bacteria and chemicals in the water. Even though water may appear clear, it can have some different things in it that affect the water quality. This could be harmful bacteria, like in the case of the Antidotes pollution solution, or it could be chemicals used to keep the water clean, such as chlorine in a swimming pool. The activity I'm going to show you today is to demonstrate that although water may appear clean, it may have substances in it which affect the properties of the water. I've already set up 3 identical jars with water, and what I'm going to do is put a fresh egg into each of these jars and see how they respond to see if there's any clues about the contents of this water. A fresh egg should sink in a jar of water. You'll notice that in the first jar the egg went down to the bottom and is sitting slightly above the base of the jar. The second egg went right the way down to the bottom and is sitting on the base of the jar, and the third egg is floating on top of the water. Why did I get this result from the eggs in 3 jars of seemingly clean water? This is because I set the jars up last night with different solutions that have affected the properties of the water. One of the jars I labelled control, and I simply filled this with 1.5 cups of boiling water. Another jar I labelled sugar, and I filled this with 1.5 cups of water and then dissolved 1/4 cup of sugar into it. The third jar I labelled salt, and again filled this with 1.5 cups of water and then put 1/4 cup of salt into it. Once I'd set up the solution, I put the 3 jars up on my kitchen counter, leaving them to cool and be ready for filming today. You'll notice that even though I filled up each of these jars with the same volume of water, which was 1.5 cups, the water level is higher in the jar on the left, which is the sugar jar, and the jar on the right, which is the salt jar. That is because by dissolving these 2 substances in the water, I have changed the properties of the water, and the property I have affected is its density. Density is worked out by the mass divided by the area that something takes up. Normally, an egg is more dense than water, and that is why it sinks to the bottom. The exception to this would be a raw egg, which as it starts to go off becomes lighter than water, and that is actually a good way to test if your eggs are fresh or not. In the sugar jar, I've not added enough sugar to be able to affect the density that much to have the egg floating up at the surface of the water. With the salt jar, however, I have added enough salt to have that egg floating at the surface of the water. This test shows that there is an invisible substance in these jars of water, that although they all looked clean, they don't all respond the way that we would expect clean water to respond. You can have a bit of fun with this yourself by changing the quantity of sugar and salt that you add into the jars. You could explore how much sugar you need to add to get the egg floating, or how much salt you need to add before the egg starts floating, or you could try and test it to see if you can get the egg to float in the middle of the jar. There's lots of different ways you can take this experiment forward, but it is a good simple one to show that clear water doesn't always mean that there are not other substances within the water. Now it is time to explore a claim which sometimes goes around online using an experiment in scientific language which seemingly demonstrates that tap water is unsafe. For this experiment, I'm using 2 identical glasses, one of which I'm going to fill up with tap water and the other one I'm going to fill up with distilled water. Now what I'm going to do is add this electrolyser into the glasses. You'll notice that it has two sets of 2 electrodes, and that means I can test 2 samples side by side at the same time. What the electrolyser will do is pass an electrical current into the water. I'm looking to see if there are any changes happening to the water. So let's put the electrolyser in and find out. Electrolysis is a process of using electricity to split something into its component elements. For example, with water, that would be oxygen and hydrogen. For electrolysis to work, something has to be added to the water, such as an acid or salt. As this experiment goes on, you'll notice that the tap water is fizzing and starting to develop a colour. First a yellow, then an orange, and then a sort of murky brown colour. Whereas the distilled water is not fizzing and is not changing colour at all. Now that this experiment is done, I've got a clear distinction between my distilled water and my tap water. And this experiment is often used by people claiming that tap water contains harmful substances that are dumbing us down. But what is the true science behind this experiment? Because it is not that false claim. Well, tap water contains substances which allow it to conduct electricity more easily, such as calcium. Distilled water is water which has been boiled and then recondensed, meaning that a lot of the substances that were originally in it are now out of the water, so it is as pure as the water can get. This doesn't mean that tap water is bad for you. It has natural nutrients in it which allow it to conduct electricity. The colour change is actually coming from the breaking down of the electrodes which are placed into the water. Each side of this electrolyser contains an aluminium and an iron electrode. Now, when an iron electrode is placed in water and electrical current is passed through it, the iron electrode starts to break down, releasing coloured ions into the water. And that is what is causing this colour change. The reason we don't get that in the distilled water is because the distilled water is not conducting the electricity, but the tap water is, because, as I've said, it contains those natural nutrients. Actually, when I took the electrolyser out of the water, you can clearly see that the iron electrode has a section on it which is not as clean as the section of the electrode that was not in the water, showing that the bottom part of this electrode has broken down. This is just fake science, which is put out there to push a claim about the harmfulness of tap water, whereas in fact there is nothing actually harmful in the tap water. It is the breaking down of the electrode. So this electrolyser here is really not worth the money I spent on it to demonstrate this to you, but it's important to highlight false science out there so that you don't get duped by these claims and you understand the true science of what is going on in these experiments. Well, that's all for this week. I hope you enjoyed it. A big thank you to Patty Michelle, the author of the Antidotes Pollution Solution. I've put links in the description to where you can purchase the Antidotes Pollution Solution. I don't receive any commission for your purchase. I just think it is a great book to introduce children to STEM skills. As always, I would like to take this opportunity to answer any science questions you have about any science topics at all. So feel free to email me at stemwithmrn@outlook.com and I'll get back to you with answers to your questions. You can subscribe to the channel by pushing the button here, and I've added links here to the other STEM demonstration and explanation videos I do, here to my 10 things you should know about series, and here to my series on 100 scientists who influenced the world. This has been STEM with Mr. N, exploring invisible water quality.